This video will be covering everything you need to know for the geometry regents. Okay, let's start off with the basics. So this is what a point is, this is what a line is, this is what a line segment is. You can see that there's no arrows. And then an array only has one arrow, and this is what a plane is. Okay, so let's go over the basic postulates and properties that you should know. So the segment addition postulate basically says that if point B is between point A and C on a line segment, then AB plus BC is equal to AC. The angle addition postulate says that if D is the interior of angle ABC, then angle ABD, which is this angle right here, plus angle BDC, this angle right here, is going to be equal to the angle ABC. So here are just some algebraic properties that you should know. The addition property basically says that if A is equal to B, then A plus C is equal to B plus C. And the subtraction property is kind of the same thing, but instead of adding C, it's subtracting. And multiplication is just multiplying C instead of adding or subtracting. And then division is dividing by C. The substitution property says that if A is equal to B, then A can be substituted by B in any equation. So here's just an example of an angle and line segment proof. So if we're given angle F is congruent to angle G, prove that angle AEC is congruent to angle BED. So first we have what's given, right? Angle F is congruent to angle G, and then we can say that angle F plus angle H is equal to angle AEC because of the angle addition postulate that we just went over. And then we can say that angle H plus angle G is equal to angle BED, also because of the angle addition postulate. And then we can say that angle F plus angle H is equal to angle G plus angle H because of the addition property. And then angle AEC is congruent to angle BED because of the substitution property. Okay, the distance formula is pretty important for this test. Here it is. And we can use this formula to find the length of a line segment between 2 points, or we can use it to check if line segments are congruent to each other. The midpoint formula is this formula right here. And here's just an example of how to apply it. Usually you're given 2 coordinates, and here's just what x1, y1, and x2, y2 are. So we just plug it into the formula, right? And then we get this. The coordinate we get here is going to be the point that's between these 2 coordinates that we're given. So the coordinate we get is just going to be the midpoint between these 2 coordinates that were given in the question. Some proofs that you may be asked to do is to prove a triangle isosceles. We can just show that 2 sides are congruent to each other by using the distance formula, and then prove a triangle is right triangle by showing that there are perpendicular lines. You can use the slope formula, and if the 2 slopes are opposite reciprocals, you know that they are perpendicular lines. You can also use the midpoint formula to prove a midpoint or a bisector, and to prove parallelogram, rectangle, rhombus, or squares that exist. You can use the slope or distance formula to determine perpendicular or parallel lines and congruent sides. Okay, so surface area is the total area of all surfaces and faces of a 3D object. So you don't want to mistake that for, volume, because we're just accounting for the surfaces and faces of the 3D object. So for all prisms and pyramids, you want to find the area of each face and add them together. For cylinders, you want to find the area of 2 circles, because a cylinder has 2 circles, right? And then you want to add the lateral area, which is basically this. It's kind of like when you unravel the shape. To find the surface area of a cone, you want to find the area of the base circle and then add the lateral area. And the lateral areas for the cylinders and cones will be given on your reference sheet. You can see that there's the lateral areas for the circular cylinder and the circular cone. The surface area of a sphere is also given, and then the area of a circle is just pi radius squared. So volume formulas are also something that's going to be important. Just remember for general prisms and pyramids, the uppercase B is just equal to length times width. Okay, so you have to know these following angle relationships. So a complementary angle is where the sum adds up to 90 degrees. Supplementary angle is when the sum is equal to 80 degrees. Adjacent angles are angles that share a common side and vertex, so they're adjacent to each other, right next to each other. Vertical angles are just opposite angles formed by intersecting lines, and they're congruent to each other, right? So angle 1 would be congruent to angle 2. These 2 angles would be congruent, and then these 2 angles would be congruent. A linear pair are just adjacent angles that form a straight line, and they are supplementary to each other. The different types of angles that are formed by parallel lines cut by a transversal. 1 and 5 are corresponding angles. 5 and 8 are vertical angles. 6 and 4 are consecutive angles. 7 and 8 are supplementary angles. So this diagram just kind of shows you where exterior and interior angles lie. So the area between the two parallel lines are the interior angles, and then the area that are outside is the exterior angles. Here are just some parallel proofs. So corresponding angles are congruent to each other. Alternate exterior angles are congruent to each other. Alternate interior angles are congruent to each other. And consecutive interior angles are supplementary to each other, which means that they add up to 180 degrees. Here's the slope formula. If the slopes of two lines are congruent to each other, that means that there are parallel lines. If the slope of two lines are opposite reciprocals, then that means that they are perpendicular lines. And what an opposite reciprocal basically is you just find the inverse of it and then negate the number. So for example, 2 would be equal to negative 1/2, and then 1/2 would be equal to negative 2. Here are just some transformations. There are two types of transformations, right? So there's rigid motions, which preserves the angle measure in the distance, which means that it'll be the same size and shape. Okay, so translation is where you just move it up, down, or left and right. Here's the notation for it. A reflection, it can be either over the x-axis or the y-axis, or the line y equals x. Here's the notation for it. Keep in mind that it's a small lowercase r instead of an uppercase. And then a rotation, you can rotate 90 degrees counterclockwise, 180 degrees, or 270 degrees. And here is the notation for it. And see how it's an uppercase r instead of a lowercase. And here is the degree that it rotates by. I only provided one example, but you can replace the 90 with like 180 and 270 and change this section right here. So non-rigid motion is a transformation that preserves angle but not the distance. So the size is the same, but the shape is different. What you do is you just multiply x and y by a scale factor, which you can see here is k. And if k is greater than 1, then that means it's an enlargement. If k is between 0 and 1, that's a reduction. And dilation is represented by this notation. It's d and then the scale factor, and then multiply the scale factor by x and y. Okay, so something to keep in mind when you see this circle right here, you want to make sure to do the right side first and then to do the left side. Okay, so regular polygons are just polygons where all sides and angles are congruent to each other. Here are just some angle rules. So interior angles, the sum of interior angles is equal to the number of sides minus 2 times 180 degrees. Each interior angle is just equal to sum of interior angles divided by the number of sides. And you want to remember that interior angles cannot be greater than 180 degrees. And exterior angles, which are the blue angles right here, each exterior angle is equal to 360 degrees divided by the number of sides. And the sum of exterior angles is always going to be 360 degrees. So the triangle sum theorem basically states that the sum of all interior angles in a triangle is equal to 180 degrees. So angle A plus angle B plus angle C is going to be equal to 180 degrees. And something to keep in mind for triangles is small side will be always opposite to the smallest angle, and then the largest side will be opposite to the largest angle. The triangle inequality theorem basically says that the sum of any two sides of a triangle is greater than the third side. So if the sum of two sides of a triangle is less than the third side, the triangle does not exist. So here are just the different ways the inequalities can work. So here are just two theorems that apply to isosceles triangles. So isosceles triangles theorem basically says that if two sides of a triangle are congruent to each other, then the angles opposite of those sides are congruent to each other. The converse of this theorem says that if two angles of a triangle are congruent, then the sides opposite of those angles are congruent to each other too. Here's the Pythagorean theorem. A squared plus b squared is equal to c squared. A is always the smallest value, B is the second smallest, and C is always the largest value. And here are just some Pythagorean triples that you have to remember. So the 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. And the multiples of each of these four is also a Pythagorean triple. So if we multiply this by like 3, 3, and 3, so 9, 12, and 15. That's also a Pythagorean triple. Okay, so here are just two special triangle relationships, special right triangle relationships. So 45, 45, 90 triangle, and then the 30, 60, 90 triangle. So what these are helpful for is if you're ever given like only one side of a right triangle, right, and we know that it's a 45, 45, 90 triangle, you can use this one side to determine the other two sides. But you can always just memorize like the side lengths and the angles that are associated with it. So you can memorize the 1, the 2, and then the radical 3, and then the radical 2 on the hypotenuse here, and then the 1s for the side lengths. Remember the trig functions that are associated with the special right triangles. We can just do 30s And we can do 1, 2, 3, 3, 2, 1, and 3, 1, 3. And we put them all over 2. Except for this one is over 3. And then we put a radical on everything that's not a 1. So here's just one way to memorize it. Okay, trig ratios are used to find unknown sine lengths or angles in right triangles. So right here we have theta, right? The side opposite to theta is known as the opposite side. The side adjacent to theta is known as the adjacent side. And the side opposite to the 90-degree angle is known as the hypotenuse. So we can just remember SOHCAHTOA, right? For our trig ratios, we know that sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And then tangent is equal to opposite over adjacent. Find the functions of angles greater than 90 degrees. So right here we have the example sine of 715. First, we have to find what quadrant this angle is in. So if we have this axis right here, and we know that this is 360, this is 90, 180, 270, and if it goes around one time, it's 360, right? If it goes around 2 times, it's 360 times 2, which is equal to 720. So angle 715 would be somewhere around here in the 4th quadrant. Okay, to find the sine of that function, we can use all students take calculus. All the functions in the 1st quadrant are going to be positive. Only the sine in the 2nd quadrant is going to be positive. Only tangent in the 3rd quadrant is going to be positive, and only cosine in the 4th quadrant is going to be positive. Sine of 715 is in the 4th quadrant, so that means that it'll be negative. Now we have to determine the reference angle. We can do 715 minus 360, which is equal to 355. And 355 is pretty close to 360, so we can just do 360 minus 355 to give us 5. So the reference angle is going to be 5. We know that since it's in the 4th quadrant and it's sine, it's going to be negative. So we can do negative sine 5 is going to be equal to around negative 0.0872. Okay, so what cofunctions are is the sine of one angle is equal to the cosine of its complementary angle. So these functions are known as cofunctions, and they have to be acute angles. So for example, the sine of 37 would be equal to the cosine of 53, because 90 minus 37 is equal to 53, so 37 and 53 are complementary angles. So to find the area of a triangle using trig, when you're given 2 sides and the angle between the sides, so side, angle, side, you can use the formulas below to find the area of any triangle. So like I said, it's going to have to be side, angle, side, and it has to be in this orientation or else it's not going to work. And then here are the following equations that you can use. So the law of sine states that in any triangle, the ratios of length of a side to the sine of the opposite angle are constant. So this law of sines can be used to find any missing angles or sides in a triangle when 2 other sides and an angle are given, or when 2 angles and a side is given. So when you're given angle, angle, side, or angle, side, angle, and it has to be in that orientation of a triangle, you can use it to find any missing angles or sine lengths. So the law of sines is just A over the sine of A equal to B over the sine of B, and then C over the sine of C. Okay, so the law of sines, the ambiguous case, is used over the same thing, right? It's used to find any missing side lengths or angles. So in this case, you're only given side, angle, side, right? You're only given, like, say, the sides 5 and 6, and then an angle 20 right here. But the problem with this is there can be different numbers of distinct triangles that can be formed under this condition. So we want to find the number of distinct triangles that can be formed, right? And to do that, we're going to have to find what this angle x is and then determine the height of the triangle, right? And the reason for this is, so let's say we have angle 5. So we have sine length 5 right here, right? We can see that it's not restricted, right? Because we don't know what angle x is. So sine length 5 could be over here, it could be over here, or it could be over here, right? Because it's not restricted, so it can kind of like rotate around this point right here. So you have to determine the height and then compare it with what's given, right? 5 to see if it's gonna form 0, 1, or 2 triangles. So angles of elevation and depression. The angle of elevation is just the angle formed by a horizontal line, an observer line to the site of the object above the horizontal line. And then the angle of depression is just formed by a horizontal line and then an observer's line of sight to an object below the horizontal line. And these two angles are alternate interior angles, which means that they're congruent to each other. And here's just a visual representation. If the man is looking up to the bird above the horizontal line, that's an angle of elevation. And then the bird is looking below the horizontal line, right, at the man. So that is an angle of depression. Okay, moving on to quadrilaterals. There are many different types of quadrilaterals, and they're all like distinct in their own way. So parallelograms and the different types all have 2 pairs of parallel sides. And then for trapezoids, there's only 1 pair of parallel sides. And then kites are where there's no pairs of parallel sides. Okay, so the properties of parallelograms are that opposite sides are parallel or congruent to each other, consecutive angles are supplementary to each other, the diagonals bisect each other, and then the opposite angles are congruent to each other. And then the area of parallelograms is just base times height. And then the properties of rectangles are that opposite sides are congruent and parallel to each other, all angles are right angles, the length of the diagonals are congruent to each other, and the diagonals bisect each other. And the area of a rectangle is equal to length times width. For rhombuses, all sides are congruent to each other, opposite sides are parallel to each other, opposite angles are congruent, and diagonals bisect each other at right angles, and the diagonals also bisect the angles. So area of a rhombus is equal to base times height, or is equal to 1/2 multiplied by the first diagonal times the second diagonal. So squares, all sides are congruent to each other and parallel to each other. All angles are congruent because they are right angles. The lengths of the diagonals are congruent to each other. The diagonals, like the rhombuses, they bisect the angles as well. And the area of a square is just equal to length times width, or one side squared, because all the side lengths are congruent to each other. For kites, remember they have no pairs of parallel lines, right? So 2 pairs of congruent adjacent sides. The diagonals are perpendicular to each other, which means that they form right angles, and one diagonal bisects the other. So this is the longer diagonal bisects the shorter diagonal. So the area of a kite is equal to 1/2 times the first diagonal times the second diagonal. Okay, so moving on to trapezoids, there are 3 types of trapezoids that you need to remember. The scaling trapezoid only has 1 pair of parallel sides, which are known as the bases, and then the supplementary consecutive interior angles that exist are these 2 pairs right here. So if you add them up together, it's going to be equal to 180 degrees. You can kind of imagine them because these 2 are the parallel lines, right? And then these 2 are the transversals. So if you add this angle and this angle together, it's going to be 180 degrees. And if you add this angle and this angle together, it's going to be 180 degrees as well. So isosceles triangles only has 1 pair of parallel sides, and then 1 pair of congruent sides as well, which are known as the legs. And the base angles are congruent to each other, and the diagonals are congruent to each other as well. For a right trapezoid, 2 right angles are formed at the base where the legs meet. The height is the length of the perpendicular leg, and the 1 pair of consecutive angles, because once again, these are parallel lines, and then you can imagine this as the transversal. And then to identify quadrilaterals in the coordinate plane, you want to remember the distance formula and also the slope formula. And again, if the slopes of 2 lines are congruent to each other, then parallel lines exist. If the slope of 2 lines are opposite reciprocals, and that means that they're perpendicular lines. So these are just the different ways to identify different quadrilaterals using the distance and slope formulas. So to prove that a rhombus exists, you want to prove that there are 4 congruent sides using the distance formula, and then you want to prove that the sides are not perpendicular to each other, right, using the slope formula. Because if there are perpendicular sides, then that means right angles exist, and that means it's a square, not a rhombus. To identify a rectangle, you want to prove that all 4 sides are perpendicular to each other using the slope formula. And to prove that it's not a square, you want to prove that there are only 2 pairs of congruent sides using the distance formula. Because if all 4 sides are congruent to each other, that's a square. To identify a square, you want to prove that it has 4 congruent sides using distance formula, and then prove that all sides are perpendicular to each other using the slope formula. And for trapezoid, prove that there is only one pair of parallel sides using the slope formula. And you want to make sure to find the slope of all 4 sides just to make sure that there's only one pair, not 2. To identify a isosceles trapezoid, you want to prove that there's only one pair of parallel sides using the slope formula, and then use the distance formula to prove that there's only one pair of congruent sides, basically the non-parallel sides. And lastly, to prove a right trapezoid, you want to prove that there's only one pair of parallel sides using the slope formula, and prove that there's a perpendicular side using the slope formula as well. Okay, moving on to centers of a triangle, the different points of concurrency. So the centroid is just the intersections of the medians, and the median is just from the vertex to the midpoint on the opposite side. It's important to remember that the medians intersect at a 2-to-1 ratio. So this would be 1, and this would be 2, 2, 1, and 2, 1. The orthocenter is the intersections of the altitudes, and the altitudes is just the perpendicular segment from a side to the opposite vertex. The incenter is the intersections of the angle bisectors. They're equidistant from all 3 sides, and then the incenter is also the center of the incircle. Okay, so 2 figures are similar to each other if you can get one figure from another through a sequence of dilations of transformations. So they include both rigid and non-rigid motions. The image will have the same shape as its pre-image, which basically means that it'll be similar to each other, right? 2 similar figures have corresponding angles, congruent, corresponding sides in proportion. They don't have to be congruent to each other, or else it will be 2 congruent figures. Okay, moving on to similar triangle proofs, the angle-angle similarity theorem, the side-side-side similarity theorem, the side-angle-side similarity theorem, and then knowing that corresponding sides of a similar triangle are proportional to each other. So when a line is drawn parallel to one side of a triangle, it creates a smaller triangle that is similar to the original triangle. So they're going to have the same like proportions. So the triangle proportionality theorem basically says that if a line is drawn parallel to one side of a triangle and intersects the 2 other sides, it divides those 2 sides proportionally. So like these 2 sides would be in proportion. The converse of this theorem basically just says that if a line divides 2 sides of a triangle proportionally, the line must be parallel to the 3rd side. So the midsegment or midline theorem basically is when a line segment joins the midpoints of 2 sides of a triangle. So if this is the midpoint, that means that these are congruent to each other and these are congruent to each other. So it splits the line into 2 congruent segments, and this segment is parallel to the 3rd side of the triangle. And it divides the triangle into 2 similar triangles, and the length of the mixed segment is half of the length of the 3rd side. So DE is half the length of BC. So here are just some proof statements for congruency, not similarity. So the side, angle, angle, and angle, side. And also the hypotenuse leg situation, which is only for right triangles. And then CP-CTC, which is often used after proving 2 triangles similar to prove like angles or side lengths congruent to each other. So the hypotenuse leg is basically where you have to prove the hypotenuse of a triangle and the leg of a triangle congruent to each other to prove that it's a right triangle. So moving on to circles, right? We're going to go over the different parts of a circle first. This is the center. This is the radius, which is a line segment that connects the center to a point on the circle. And then a chord is connecting 2 points on the circle. Diameter is a chord that passes through the center. The secant is a line that intersects the circle twice. A tangent is a line that intersects the circle once. And the arcs, it's important to remember that a minor arc is from 0 to 180 degrees and is always considered unless otherwise stated. And then the major arc is 180 degrees to 360 degrees. A semicircle is just an arc whose endpoint is equal to the endpoints of a diameter. So the different angles are formed in circles. The central angle is formed by 2 radii. The measure of the angle is equal to the measure of the arc, and then congruent arcs have congruent central angles. And inscribed angles are formed by 2 chords. The angle measure is equal to 1/2 the measure of the arc, or the arc is double of the angle. Congruent arcs have congruent inscribed angles. And an angle formed by a tangent and a chord, the angle is equal to 1/2 of the arc. Angle formed by 2 chords that are intersecting, the angle is equal to 1/2 the sum of the two intercepted arcs. An angle formed by two secants or tangents. So on the left you have the two secants, and on the right you have the two tangents. The angle is equal to 1/2 the major arc minus the minor arc, or it could just be the bigger angle minus the smaller angle. Okay, so when two chords intersect, when you multiply AP by PB, it is equal to CP times PD. And when two secants intersect, PQ times SQ, this line segment, times the smaller line segment, is going to be equal to RQ times TQ. And when a tangent and secant meet at a point, if you take the tangent and you square it, it is going to be equal to the external segment multiplied by the whole secant. So for inscribed quadrilaterals, this is basically talking about when a quad is inscribed inside a circle. It's just saying that if this is the case, then the opposite angles are supplementary to each other. So angle A plus angle C is going to be equal to 180 degrees, and then angle B plus angle D is going to be equal to 180 degrees. So moving on to locuses, this is some form of construction. So when you're asked to find the locus of all points equidistant from 2 points, you want to construct a perpendicular bisector between the points. So let's say this is A, this is B, and if you're asked to find the locus of all points equidistant from these 2 points, you want to construct a perpendicular bisector between these 2 points. So when you're asked to find something equidistant from 2 lines, you want to construct an angle bisector. Fixed distance from a point, you want to construct a circle. Fixed distance from a line, you want to construct parallel lines. So constructions, there's always going to be one construction on the geometry regions. So I'm just go over them really quickly. The perpendicular bisector of the segment, you have your line segment right here, right? You want to use your compass and you want to kind of drag it past the kind of middle point, closer to point A. You want to make an arc, and then keeping the same shape of your compass, you want to draw another arc from point A. And then there is your perpendicular bisector. And then perpendicular line from a point on the line. This is not always the midpoint, right? So when we have to construct the perpendicular line from that point, this is not always the midpoint, so it's different from like the perpendicular bisector. We want to hold our compass at point E, and then we want to draw an arc that intersects the segment AB twice, and then we want to make an arc there, and then keep the same shape of your compass and draw another arc, and then construct the perpendicular line. And then perpendicular line from point not on the line, make your compass, make 2 marks on line AB, and then you want to move it there to make 1 arc, and then at that intersection, with the same shape of your compass, and then construct the line. And then for angle bisector, let's say we have angle ABC, right? We want to put the compass on point B and then construct an arc that intersects both lines. And then we want to move it to the intersection points and make 2 arcs that are the same shape. And then there is your angle bisector. And to copy an angle, we have an angle right here. We just want to make a ray first using your straight edge. And basically what you're going to do is just copy the same arcs using your compass from the angle to the ray. So we have this arc right here, it's the same size. From this intersection on point BC, we're going to put our compass there and then make an arc right there. And then do the same thing for the ray. We're going to go on this intersection point and then make an arc. And then draw the line and you've copied your angle. And to copy a segment, this is pretty easy. We have your segment right here. We're going to construct a ray using your straight edge. And then we're just going to take the compass and copy over the same distance by not changing how wide you move your compass. Okay, so to construct an equilateral triangle, right here I have a line segment, but you're not always going to be given a line segment, right? So you want to construct that with your straight edge, and then you want to copy the distance of it using your compass, and then you just want to copy that onto the top right there, and then copy that from this point right here again to create an intersection, and then connect all points to create an equilateral triangle. To construct a square in a circle, you want to first create a diameter in the circle, and then from that diameter you want to start creating a perpendicular bisector, right? So from these 2 intersection points, you want to create the particular bisector. Then to connect all points, you're going to get a square.